Hey, greetings geometry students. Here is our last section, I believe, of the year. Don't quote me on that, but I'm pretty sure that's going to be it. So let's get started. Today we're going to be dealing with the surface area of and volume of spheres. So again, surface area is a unit squared and volume is a unit cube. So let's deal with the first. Okay. Actually, we need to cover some grammar. So again, our Larson book here, and here we've got the grammar going on here. We didn't cover all this grammar. Weren't able to cover chapter 10, but again, a chord. It's got a picture of a chord cutting it from end point to end, cutting through here, end point to end point. We already know what a diameter of a circle is, or the diameter of a sphere is from end to end, but must pass through the center. Radius is from the center out to the edge. So anywhere, I mean, you can go here, there to there. So there we go. All right. So we've got our surface area of a sphere. S equals 4 pi r squared. Again, squared units. And then over here, I thought this was pretty interesting. A great circle. All right. We've got a great circle going on here. If you have a sphere that's cut through by a plane, it says a great circle of sphere. If a plane contains the center of the sphere, then the intersection is a great circle. So if you have a plane that cuts through, it's going to cuts through the middle, or where the center is, it's going to form a great circle. Okay. It says if a plane intersects a sphere and cuts, it'll either be a single plane or a circle. So say I cut like this, like and just barely touch the top, that plane, they touch at one point. But if I cut a little bit lower, maybe at this angle, that inside there will form a circle. If I were to cut, if I were to take and cut along here, like at this angle here, and cut like that, in 3D and 2D, it'd form a circle. Okay, that's all that's saying. Well, let's dive into this. So I want to do the guided practice number, which one was that did I want to do? I want to do a sphere. Let's see. Yes, I want to do let me set it up here. So let's say I had a sphere with diameter 6 feet. Okay, we have to pay very careful attention to diameter and radius. Okay, you know the formula is 4 pi r squared. And we'll cover this in here in a moment, and I'll talk about that, but I want to just write it down. The formula is 4/3 pi r cubed, okay? And so if they have a diameter of 6, we know that the radius is half of that. I went ahead and kept these in terms of pi, so again, with the radius of 6, diameter of 6, that's going to be a radius of 3, so 3 squared is 9, 9 times 4 is 12, keeping in terms of pi, 12 pi. And then over here, volume, 4/3 pi r cubed. 6 divided by 2 is 3. 3 cubed is 27. 27 times 4 divided by 3 is 36. And we have 36 pi. So feet cubed and feet squared. Now again, if it said round to the nearest tenth or something, then you'd multiply by pi. But if it says keep in terms of pi, leave it in terms of pi. Okay? Let's move on to the next one. Alright, so the derivation is not derivative, but the derivation. How did I derive? How did I arrive? How did I get to this formula? This is a wonderful derivation of how the volume of a sphere came about. So take a look at this. If you're interested in taking physics and you like to do algebra, this is where it's at. I love deriving formula. It's part of mathematics. Props to the ancients who came up with these formulas and allowed us to utilize them today. So, take a look at that in your book, please. All right. We're going to do another example. All right. So, suppose we have this shape here. Okay, it's kind of like maybe sometimes we're working on a lathe. It looks like to me it's a cylinder made up of 2 half circles. Okay, so we would call them semicircles. Okay, so or this would be a hemisphere. Okay, this angle doesn't look quite, but that's okay. The hemisphere, and that's a hemisphere. Okay, and hopefully you can see that if I take, we live in the northern hemisphere, If we take the whole northern hemisphere and put it together with the southern hemisphere, we have a whole sphere. All right. So these are going to be congruent, and so so we have a cylinder and two hemispheres. So two hemispheres equals a whole sphere. Okay. So surface area. Surface area is going to be, okay, so again, this is the work I want to see. So half a sphere plus another half sphere is going to be one full sphere. The surface area for a sphere is 4 pi r squared. Okay. Then we need the lateral surface area of the cylinder. The lateral surface area of the cylinder. You should remember that. The lateral surface area of the cylinder is going to be circumference multiplied by height, or 2 pi r multiplied by the height. Plug and chug, we're done. Okay, so there's the work there. Putting in the parts, radius is 2, height is 7, plug and chug. We have 138.2 centimeters squared. Don't tell anybody. Alright, let's move on to volume. Okay, set up first. Okay, so going back to the image here, I've got all the work done, but this is going to be a hemisphere plus the same congruent hemisphere, so that equals the whole sphere. Okay, the volume of the sphere, and then we have volume of cylinder. Remember, volume doesn't matter, like it's the formula is different. Okay, so surface area is what on the outside, or if there's like the one where we had a dip in there and we had the inside. All right, but volume is how much units it can be made up of. So 4/3 pi r cubed plus BH. All right, we know that BH can also be the area of the base can be simplified to pi r squared, and then H. So the radius for each of these are the same, and then the height is 7. Plugging in the parts where they belong, and again showing your work. Now, as you showed your work right here, if you got right here, just you could jump right down here to put it on a calculator. But again, don't make any calc errors. Okay, and I like to check my work to see if it makes sense, because really this volume of this cylinder should be larger than the sphere. So because I can draw like a sphere in right up here, I can draw a sphere in, and so my math number sense here, looking at a sphere. This sphere, like if this is a tennis ball, if I put one tennis ball right here, I've got probably room for 2 other tennis balls plus room to spare. So if I go in this and I find this, and this one's 87.9, if I look at this is almost 3 times larger. So that stands to reason I probably could fit 3 tennis balls if I had 3 tennis balls in this space, almost. Okay. Not quite, but almost. So that's why I like to sometimes show these so that my number sense. So I get a number and I go back and go, does that make sense? Always a good thing in mathematics to pause and do. One more. Alright, so the last one we're going to do is number 5. Okay, a solid consists of a hemisphere of radius 1 meter on top of a cone with the same radius and a height of 5 meters. Find the volume of this solid, round your answers to 2 decimal places. Okay, a little scribble there with the post-it means the answer's underneath there, and I don't want you to see the answer yet. Okay, so let's work this. First off, we have to take what in the world does this mean? What does this mean to me? Well, I always like drawing a sketch. Sketch helps me visualize what these words mean. Yeah. Okay, so just a quick sketch. You guessed it, looks like an ice cream cone. Okay, I didn't really do my sketching lines there of the waffle cone there, but you know, makes me hungry for going to get some Baskin Robbins. So, yummy. Let me draw the angles in, or the values in. Okay, so this is no longer an ice cream cone. This is more like an ice cream like outside, sitting outside the store on top of the billboard or something like this, 5 meters tall. That's pretty large. Okay, and with a 1 meter long radius. Okay, again, we're going to do surface area and we're going to do volume. So set up first. Okay, so again, the surface area is going to be a hemisphere, all right, plus the lateral surface area of a cone. Let me get that. Lateral surface area of a cone. Okay, so hemisphere and the lateral surface area of a cone, not the inside. Okay, so that's going to be 1/2, because it's a hemisphere, 4 pi r squared. Okay, which reduces to 2 pi r squared. And then lateral is 1/2 circumference times slant height. Okay, so that's circumference is 2 pi r, which this will reduce to pi r, then multiplied by the slant height. slant height. I already did it down here. So this forms a right triangle. Let me put L in there. That's what we want. The hypotenuse, which is slant height. 5 so square root of 26. Okay, which is approximately 5.1. It's not much bigger than this. So plug in the parts. Booyah. Alright, so plugging the parts in where they belong. So 6.28 meters squared for the hemisphere and 16.02 for the area or surface area of the cone. Okay. Again, this is enlarged. This is a 1 meter radius, so it's not as big. This does not. My distance here, it's out of scale. My distance here of 1 meter, that doesn't match the 5. It'd be more like that amount. So, okay. It's out of scale, but I wanted to draw an ice cream cone because I could. Alright, so let's do volume. Alright, so hopefully you've seen that. I find volume much easier to get than surface area. Okay, so volume of cone is going to be the volume of the hemisphere plus the volume of the cone. Or I'm sorry, the volume of this whole figure. So volume of a hemisphere, hemi, plus volume of the cone is going to be 1/2, because it's half of 1, 4 pi r cubed, plus 1/3 base area of the base times height, which is 1/3 pi r squared h. Okay, remember, area of the base of a circle is pi r squared. So plugging in the parts, here we are, and again, meters, units, meters times meters is meters cubed. Okay, 2/3 times pi is 2.09, but a meter times a meter times a meter is a meter cubed. All right, then 1/3 pi multiplied by 1 meter squared. So 1 squared is 1, but meter times meter, so meter squared, multiplied by another meter is a meter cubed. Okay, adding these up, and then the big reveal. 7.33 meters cubed. Okay, 7.33 meters cubed. That is all we have for today. So, may the good Lord bless and keep you, and have a great, whatever day it is. All right, bye.